Does the moon only exist? When you look at it, this isn't some philosophical brain teaser. This is a question Albert Einstein actually asked, and the answer will shatter everything you thought you knew about reality. Back in 1935, Einstein published a paper that should have rocked the very core of science. He called it the EPR paradox. EPR. That stands for Einstein, Podolsky, and Rosen, the three brilliant physicists who put it together. And in that paper, Einstein proved something that at first seemed impossible. He proved that observation, that the simple act of looking at something fundamentally changes reality itself. The scientific establishment, they panicked. Because if Einstein was right, then everything we believe about the physical world, it just isn't true. Objects don't exist independently of us. Reality isn't just out there waiting to be discovered. Reality is created by the observer, by you. Over the next few minutes, I'm going to show you exactly what Einstein discovered about this observer effect. I'm going to explain why physics has been trying to hide this for almost a century, and I'm going to reveal why this discovery matters more today than ever before. If you're watching this, you're not just another viewer. You sense that reality isn't what they've told you, and you're absolutely right. Let's start with the experiment that changed everything. The double-slit experiment. This is the most famous experiment in the history of physics, and it's also the most deeply unsettling. Here's how it goes. You shoot particles, let's say photons of light, at a barrier with two slits in it. Behind the barrier is a screen, recording where the particles land. Simple enough, right? But this is where it gets weird. When you don't observe which slit each particle goes through, the particles create an interference pattern on the screen, a pattern that only waves can create. The particles behave like waves. But when you ADD a detector to observe which slit each particle is using, the interference pattern disappears. The particles behave like particles. The same particles. The same experiment. The only difference is whether or not you are watching. Read that again. The act of observation changes what the particles do, not your interaction with them, not your physical interference, just observation, just looking. Now, I want you to really understand how insane this is. The particles aren't being pushed or pulled by the detector. The detector isn't emitting any kind of force. That changes their trajectory. The detector is simply recording information. It's simply observing. And that observation, that simple act of gathering information about which path the particle took, fundamentally changes the outcome of the experiment. This has been repeated thousands of times with photons, with electrons, with atoms, with molecules, even with buckyballs. Those molecules made of 60 carbon atoms. The result is always the same. Observation changes behavior. Some scientists tried to explain this away. They said the detector must be physically interfering with the particles somehow. So they designed more sophisticated experiments where the detection was so gentle it couldn't possibly disturb the particles. The result was still the same. Observation changes behavior. They tried another approach. They delayed the detection until after the particles had already passed through the slits. Surely, if the particle has already gone through one slit or both slits, observing afterward can't change what's already happened. But it did. The observation changed the past behavior of the particles. This is when physicists started to get scared, because the implications go far beyond a simple laboratory experiment. Einstein saw this experiment and immediately understood its mind-blowing implications. If observation changes the behavior of particles, then particles don't have fixed properties. Until they are observed, they exist in what physicists call superposition, a state of all possibilities at once, and they only become definite, only become real when someone looks at them. This is what Einstein meant when he asked about the moon. If particles only become real when observed, does that mean the moon only exists? When someone looks at it, it sounds absurd, but the mathematics says yes. Einstein refused to accept this. He believed in objective reality, a universe that exists whether we look at it or not, a universe with fixed properties that are out there waiting to be discovered. He famously said, "God doesn't play dice," meaning the universe cannot be random, cannot depend on observation, cannot be created by consciousness. But here's what they don't tell you. Einstein spent the rest of his life trying to disprove the observer effect, and he failed. Every experiment he designed to prove that reality exists independently of observation backfired. Every thought experiment he created to show that particles have fixed properties proved the opposite. The observer effect is real, and Einstein knew it. In 1935, Einstein published the EPR paper. As a last, desperate attempt to prove quantum mechanics was incomplete, he argued that if particles can instantly affect each other across vast distances, then either information travels faster than light, or the particles have hidden properties we can't see. He called this spooky action at a distance, and he meant it as an insult. He thought he had found a flaw in quantum mechanics. But 30 years later, physicist John Bell proved Einstein wrong. Bell designed a mathematical test, an inequality, that would determine once and for all whether these hidden properties actually exist. The experiments were done in the 1980s by Alain Aspect, and again in 2015, with even more precision. The result? Einstein was wrong. There are no hidden properties. Particles do not have fixed states until they're observed. The observer effect is real. But wait, if Einstein was wrong, then why am I saying he predicted this would change everything? Because Einstein understood something the other physicists missed. He understood the implications. Niels Bohr and the Copenhagen School said, "The observer effect is just how quantum mechanics works. Don't ask why, just accept it and calculate. Shut up and calculate," became the motto of physics. But Einstein refused to shut up. He kept asking the dangerous question. If observation creates reality at the quantum level, what does that mean for the macro world? What does it mean for you? And for me? What does it mean for the nature of existence itself? Einstein debated Bohr at the Solvay conferences throughout the 1920s and 1930s. These debates are legendary in the history of science. Again and again, Einstein presented thought experiments to disprove the observer effect. Again and again, Bohr found ways to defend quantum mechanics. The official story is that Bohr won and Einstein lost. Physicist John Bell later summarized the debates this way. He said Bohr was inconsistent, unclear, willfully obscure, and right. Einstein was consistent, clear, down to earth, and wrong. But that summary misses something crucial. Einstein was not wrong about the implications. He was wrong about whether quantum mechanics was complete. But he was absolutely right that the observer effect has profound consequences for our understanding of reality. Bohr wanted physicists to stop asking philosophical questions. Einstein refused. And the questions Einstein asked, they still have not been answered. Here is what they do not tell you. The debates never actually ended. Einstein was never convinced. And modern physics is starting to prove Einstein was asking the right questions all along. Let me tell you about an experiment that would have blown Einstein's mind. The Wheeler delayed choice experiment. John Archibald Wheeler proposed this in 1978, more than 20 years after Einstein died. And it proves something even more disturbing than the double-slit experiment. Here is how it works. You set up the double-slit experiment, but you wait until after the particle has already passed through the slits, before deciding whether to observe which path it took. Think about that. The particle has already traveled through the apparatus. It has already gone through one slit or both slits. Its behavior is already determined, or is it? Wheeler showed that your choice of whether to observe, even after the particle has passed, determines whether it behaved like a wave or a particle. Your future choice affects the particle's past behavior. This is not science fiction. This experiment has been done multiple times with increasing precision. In 2017, scientists extended it to satellite scale, thousands of kilometers. The results were the same. In cosmic versions of the experiment, photons emitted billions of years ago show behavior determined by choices made today. Let me repeat that. Photons that left distant galaxies billions of years ago. Their behavior, wave or particle, is determined by whether you choose to observe them today. Your observation in the present affects events in the past. Stop and think about what this means. Those photons traveled through space for billions of years. They existed in some undefined state, neither wave nor particle, for longer than Earth has existed. And then today, right now, a scientist makes a choice about how to observe them. And that choice determines how those photons behaved billions of years ago. This is not speculation. This is not interpretation. This is experimental fact. The delayed choice experiment has been called the strangest experiment in quantum physics. And it directly confirms what Einstein warned us about in 1935. The past is not fixed. Observation matters. Reality is created, not discovered. Some physicists try to explain this away. They say the photons were always in superposition. They say no information travels backward in time. They say it is just how quantum mechanics works, and we should not think about it too deeply. But that is exactly what Bohr told Einstein. Do not think about it, just calculate. Einstein refused to stop thinking, and so should you. Einstein warned us. In his debates with Bohr, he said that quantum mechanics leads to absurd conclusions. He thought he was pointing out flaws in the theory, but the experiments show he was actually describing how reality works. If you have been paying attention, you realize what this means. Time is not what we think it is. The past is not fixed. The future is not predetermined. And the present moment, the moment of observation, is where reality is created. This is not mysticism. This is experimental physics, repeated thousands of times, in labs around the world, with increasingly sophisticated equipment. The observer effect is real, and it does not stop at the quantum level. Here is where it gets really interesting. In 2019, physicists at Griffith University in Australia showed that the observer effect scales up. Larger and larger systems can be put into superposition. Molecules, viruses, eventually, perhaps, cats. Remember Schrödinger's cat? The thought experiment where a cat is both alive and dead until observed. It was meant as a joke. A way to show how absurd quantum mechanics is. But the experiments suggest it might be literally true. Eugene Wigner took this further. He asked what happens if a friend observes the cat before you do. Does the cat become definite for your friend, while remaining in superposition for you? Wigner concluded that consciousness itself must be the final observer. The thing that collapses the wave function. The thing that creates reality. This is called the von Neumann-Wigner interpretation. And while it is not the mainstream view, it has never been disproven. The role of consciousness in physics remains an open question. A question Einstein was asking 90 years ago. In 2019, a physicist named Darren Edwards published a paper proposing what he calls the N-frame model. His argument is simple. If we take quantum mechanics seriously, if we follow the mathematics to its logical conclusion, then consciousness must play a role in collapsing the wave function. Not because of mysticism, but because of physics. Other physicists disagree. They propose alternative explanations. Some say larger objects collapse wave functions simply because they have more particles. Some say gravity causes collapse. Some say there are many worlds. And no collapse happens at all. But here is what all these explanations have in common. None of them are proven. None of them are universally accepted. The measurement problem in quantum mechanics remains unsolved. After 100 years, we still do not know why observation matters. We just know that it does. Einstein knew this would be the case. He knew the observer effect opened a door that physics was not ready to walk through, a door to questions about consciousness, about the nature of mind, about the relationship between observer and observed. Physics has been standing at that door for 90 years, afraid to enter. Think about what this really means for your life. If observation creates reality, then you are not a passive observer of a fixed universe. You are an active participant in creating what exists. Your attention, your focus, your observation literally shapes the world around you. This is not some new age law of attraction dressed up in scientific language. This is harder, stranger, more profound. The observer effect doesn't mean you can just wish for $1 million and suddenly it appears. It means something much deeper. It means the boundary between you and the world is not where you think it is. It means the separation between observer and observed is an illusion. It means you and the universe are entangled, just like those particles in the EPR experiment. Einstein called it spooky action at a distance. But what if the spookiest thing is how close everything actually is? What if there's no distance at all? What if the observer and observed are just two aspects of the same underlying reality? This is what Einstein was really wrestling with. Not just the mathematics of quantum mechanics, but the philosophical implications, the nature of consciousness, the nature of reality, the very nature of existence itself. If this revelation about the observer effect has opened your eyes, if you're starting to see reality differently, there's something I want to share with you. This channel exists because some of us refuse to accept the sanitized version of physics they teach in schools. Every video requires hours of research into primary sources, papers most people never read, experiments most people never hear about. When you click Super Thank, you're not just supporting a channel. You're saying, I want to understand reality as it actually is, not as institutions want me to believe it is. That button is your way of participating, of observing. And as we've just learned, observation changes everything. Now let me tell you what Einstein really understood. He understood that the observer effect is not just a quirk of quantum mechanics. It's a window into the fundamental nature of reality. In his later years, Einstein became increasingly interested in the philosophy of Spinoza. Spinoza believed that God and nature are the same thing, that there's only one substance in the universe, and that what we call mind and matter are two aspects of that one substance. Einstein called this a cosmic religious feeling. He wrote about it in letters that weren't made public until after his death. What if Einstein saw in quantum mechanics a confirmation of Spinoza? What if the observer effect proved to him that consciousness and matter are not separate? What if he understood, decades before the experiments confirmed it, that the observer and the observed are one? The physics establishment was not ready for this. They wanted equations, predictions, technology. They didn't want philosophy. They didn't want questions about consciousness. They didn't want to think about what it means. That observation creates reality. So they told everyone to shut up and calculate. And they've been shutting up ever since. But some physicists refused to stay quiet. In 2022, the Nobel Prize in Physics was awarded to Alain Aspect, John Clauser, and Anton Zeilinger. Do you know what they won it for? For experiments that proved the observer effect is real. For experiments that proved Einstein was right about the strangeness of quantum entanglement. For experiments that proved observation fundamentally changes the nature of reality. Read that again. In 2022, the Nobel Prize was given for proving what Einstein warned us about. In 1935, it took 87 years, but Einstein was vindicated. The Nobel Committee said, these experiments established the violation of Bell inequalities and pioneered quantum information science. But what does that actually mean? It means there are no hidden properties. It means particles do not have definite state until observed. It means the observer effect is not a quirk or an artifact or an interpretation. It's a fact of nature, proven beyond any reasonable doubt, awarded the highest honor in physics. Einstein predicted this and he called it absurd. He called it spooky. He spent his life trying to disprove it. But in the end, he was right about how strange reality is. He was just wrong about whether we should accept it. But you do not have to shut up. You can ask the questions Einstein asked. You can think about what it means that your observation changes reality. You can explore the implications that physics has been avoiding for 90 years. Here is what I believe Einstein predicted. The observer effect would change everything. And he was right. It changes how we understand physics. It changes how we understand consciousness. It changes how we understand ourselves. The moon might not exist when nobody looks at it, but something exists, some potential, some possibility, some quantum superposition of all the ways the moon could be. And when you look, when you observe, you collapse that superposition into one specific reality. You don't discover the moon, you create it. This is the secret. Einstein tried to tell us, this is what the physics establishment has been hiding. This is what changes everything. What do you think? Does the moon exist when nobody looks at it? Does your observation create reality? Comment, yes. If you believe consciousness shapes the physical world, comment, no. If you think I'm exaggerating, either way, I want to hear your reasoning. The debate matters, the questions matter. Just like Einstein kept debating, even when they told him to stop. I read every comment in the first 2 hours. And if this video opened your eyes, subscribe and turn on notifications. There's more to reveal about what Einstein really discovered. More experiments they don't teach in schools. More implications they don't want you to think about. The observer effect is just the beginning. Einstein asked a question 90 years ago. Does the moon exist? Only when you look at it. Physics has spent 90 years trying to avoid answering. But the experiments keep piling up. The observer effect is real. Your observation matters. And maybe, just maybe, you are more powerful than they want you to believe. Einstein predicted this would change everything. He was right. The question is, are you ready to change with it? There's one more thing I want to leave you with. In 1944, Max Planck, the father of quantum mechanics, gave a famous speech. He said, I regard consciousness as fundamental. I regard matter as derivative from consciousness. We cannot get behind consciousness. That's Max Planck, the man who ignited the quantum revolution, saying that consciousness is more fundamental than matter. Einstein knew Planck well. They were colleagues for decades, sharing countless conversations. They discussed physics and philosophy late into many nights, exploring the deepest mysteries of the universe, and both of them, independently, came to the same conclusion. Consciousness is not a byproduct of matter. Matter might actually be a byproduct of consciousness. It's a mind-blowing idea. The observer effect dramatically proves that observation shapes reality. It's not passive, it's active. But who, or what, is the observer? Is it simply the detector itself? Is it the cold, unfeeling recording device? Or is it the conscious mind that ultimately reads the results? the one that makes sense of it all? Physics, in its current form, cannot fully answer this profound question. Not yet, anyway. Maybe, just maybe, never. But the question truly matters, because the answer fundamentally determines everything. If consciousness is, in fact, fundamental, if the observer is the source of reality, rather than just a mere witness to it, then you are far more powerful than you've ever been led to believe. You are not some random accident, adrift in an indifferent universe. No, you are the universe, observing itself. You are reality, becoming aware of itself. You are the observer. That makes everything real. It's your attention that breathes life into existence. Einstein predicted the observer effect would completely change everything we thought we knew 90 years later. We are still catching up to what he understood so deeply. We're only just beginning to grasp its implications. The question is no longer whether observation changes reality. The experiments have resoundingly proven that it does. It's undeniable. The burning question now is, what are you going to do with that knowledge? How will you use this power? The moon might not even exist when nobody's looking at it. Think about that for a second. But you are looking now, and that changes everything. Welcome to the reality you create. This is your canvas. Einstein would urge you to keep questioning. Don't accept things at face value. Keep observing with intention. Keep changing everything with your awareness. Because every time you observe, you create. Every time you pay attention, reality responds. It's an interactive dance. Every time you look, the universe looks back. This is what Einstein discovered. This is the legacy he left for us. This is what changes everything. Now, you know too. What will you observe next? What world will you bring into being?